This is one of those cases where, if you don't submit a talk, they're going to pick one for you. And so they picked Istio is to networking as Kubernetes is to workloads, which I looked it up, and actually, I didn't know that philosophers invented microformats. And this is actually how you would write that. I guess philosophers also invented C++ namespace syntax. So, what do transformations look like? Right? Transformations look like, or how do you get these big things happening in industry? Well, you have to have capability, right? You need to have something that provides value. And you have to have structure around it, right? People can't just take raw capability, right? They need something that puts it into a usable form for them. And often that means putting it into a structure that works in any kind of organizational context. And then you need access. Right? Access is kind of the multiplier of these things. Right? And if you look at what has happened in the Kubernetes space, right? Containers and Docker and container runtimes provided this kind of capability, right? The ability to isolate, compute, and create hermetic things. Kubernetes provided a well-reasoned structure around that capability that allowed organizations to adopt it and to scale it out and to reuse it and do all the kind of wonderful things. And then it being open source, and donated to the CNCF Foundation, right, made it extremely accessible, right? Pretty much anybody can go take it. It's not like a vendor solution, right? You can go and do with it whatever you want to do. And you get these kind of just massive effects in the industry, right? I don't know if you guys know about super blooms, but I think there's one going on right now in Southern California. Right? You just see this absolute explosion of use, right, in all these different cases, right? And it's really exciting to see that kind of thing going on. And Matt talked a little bit earlier this morning about that kind of thing going on with Envoy, right? You're seeing just an absolute explosion of usage and extension and community around Envoy, and it's really exciting. So you want to kind of, Istio's goal was kind of do the same thing around networking, right? Envoy represents this amazing set of capabilities, right? So how do you put that in people's hands, right? What are the kinds of structures you want to put around it? And also, you want to make sure that it's accessible, right? So Istio is an open source project. And so, there's a lot of excitement here today, I think, around Istio and other projects in the kind of service mesh space. And so this is what we're all trying to do. And I'm going to talk a little bit today about just one little facet of this, and in particular around organizational structure, and it's one that I think deserves a little bit of attention. And this might be a little bit of a nerdy talk, but bear with me, because it's a very important concept. I was a little punchy last night when I was doing my slides. This is a Monty Python joke. If you don't get it, go watch more Monty Python. I want to talk about the namespace. The namespace, right, the concept that and the way Kubernetes introduced it is probably one of the most powerful things that they did in the project. Right? Not pods or deployments or all kinds of schedulers or cluster-aware load balancing. The namespace. Namespaces are very powerful things. And so, what are the values that namespaces bring? Like, why do we actually care about this stuff? And why is it important in networking? Well, namespaces are awesome, and they do lots of really interesting things. They let you name things. Probably, if you get a bunch of engineers in the room and you ask them what's the hardest problem in computer science, other than counting to 2, right, is naming things. One of the problems in naming is trying to agree with other people what your name should be. Namespaces allow you to scope naming so that you can agree on a higher level name, and then you can go crazy within your own namespace to create your own names, right? You don't have to agree with everybody all the time. They also establish conventions for things, right? And those conventions percolate into different parts of the stack. You look in Kubernetes, right? The DNS names that Kubernetes creates for services are defined by the namespaces in which the services are defined, right? As are the names and the identities of the service accounts and the names of the pods, right? So everything kind of stems from this. Namespaces also represent an organizational unit, right? A lot of people are using Kubernetes namespaces as means of defining a scope where a group of people can effectively do independent work, right? And that's very aligned with the microservices philosophy. They provide an identity domain, right? It's not just for workloads, it's for everything. Tenancy units, right? So some people are using namespaces as not just organization in terms of independent execution, but actually a harder separation, right? A trust boundary between people. And that's an important thing. They also represent a security boundary, right? If you have an identity domain, you should probably have a security boundary around your identity domain. Right? If you want something in namespace A to talk to something in namespace B, well, namespace B should be able to decide if it's allowed, and namespace A should be able to decide if it wants to. And namespaces should be hierarchical. Oops. If you think about a lot of the things above, right, about team organization and tenancy unit and security boundary, right, organizations generally think about these in a hierarchical way. Like LDAP systems are hierarchical. Right? Kubernetes namespaces are flat today, and Istio has done some things to kind of at least introduce a two-level hierarchy, so we can help admins kind of provide higher-level administrative controls. Right? Hierarchies exist so you can have top-down control. And there are definitely needs for that. They're also metaphysical. They don't really care where they are, right? They're not tied to a laptop or a data center or a phone. They can be on all of those things at once, right? Namespaces exist where you say they do, right? And that's important. So, right, namespaces can run on any compute, right? Containers, VMs, phones, anywhere, on the cloud, on-prem, in your pocket, if you can give it an identity, right? A namespace exists because there's an identity or a credential somewhere that says it does. Right? Something that has the authority to assert the existence of a namespace in that place. Right? And now we're starting to see, like, when we talk about Istio or service meshes, right, we talk a lot about compute flexibility and the ability to move workloads around or not care where the workload is. Namespaces are fundamental to that ability, right, because we tie identity to these workloads so they can belong to namespaces. So you can reason about them in the ways that I just described. So this is the world's simplest architectural diagram. I have two namespaces, A and B. They have services, X and Y. I haven't said where they are. Maybe they're on PKS, because you're cool. PKS is pretty cool. Maybe they're on a big bag of VMs, because that's what you have. Or maybe they're on Kubernetes the hard way, because you just like to be cool and a little masochistic. But it doesn't really matter, right? Namespaces can exist in any kind of deployment, in any kind of physical infrastructure, right? And they just live where your compute lives. That's weird. That is very weird. Oops. Sorry, just something going on with the slides. I'm going to correct that. Maybe. Oh, that is odd. Sorry, we are having technical difficulties. Yeah, my talk seems to have died. Well, let me tell you a story then, when you look at a nice pretty picture of a flower. Because I'm going to blame Google Docs on that one. So the pictures I was going to show you, and I did draw them last night, I promise. And I did check them 10 minutes ago before I came on stage. Right? The scenario where you have these namespaces and you have your compute, and then you have some organizational mandate to move the compute around, right? Somebody told you need to use more cloud. You were totally happy running Kubernetes the hard way on-prem or whatever your VMs, or it doesn't really matter. And how would you go about doing that, and how would you think about it? Right? And traditionally in the industry, we would do things like, hey, you would go set up a VPN, right? And I would go create a replica of the workload on another place. And what VPNs represent is infrastructural identity, right? I'm going to join network A to network B, which is not very fine-grained. And it's not aligned with the identity domain that your teams are operating in, right? Which is a namespace. And so what you would like to be able to do is when you move workloads around between compute environments, you would not like to change your access policies. You would not really even like to think about how you would address the service, right? You would still like to address this service in the namespace. And meshes help you do that, right? Because we route traffic in a way that really only relies on this kind of naming concept that we introduce and on the identities that are associated with the namespace. And so an alternative way of achieving this kind of outcome is to use the credentials, in this case, in Istio, spiffy credentials, to actually create specific VPNs end-to-end between services. In doing so, you don't really care what that traffic transits over. It could transit over a VPN. It could also transit over the public internet, right? And so that gives you an awful lot of flexibility in terms of how you choose to arrange your network, right? It also gives you cost flexibility, right? You don't necessarily have to buy the most expensive end-to-end VPN solution to actually get the kinds of properties you want out of your network. And so I can, if I was a reasonable operator, I would take my service X and I would move it onto whatever other compute I was asked to move it onto. And I would establish, just like we do in Mesh today, end-to-end trust between those two services using the credentials that the service mesh is provisioning for you. And then I would figure out how I was going to make that traffic go L3 end-to-end, right? I could put them all in the same IP space. I could route it through some L3 gateway. I could send it through a public edge load balancer. It doesn't really matter too much because you haven't affected the end-to-end trust, and you haven't affected how the systems think about addressing each other. Right, namespace is the concept that ties these two things together. And then if you have something like that set up, you can start to do some more sophisticated things, right? The example I was showing was within the same organization, right? Or within the same kind of administrative boundary. So what if I wanted to do something that was more flexible? So I have my service X, and maybe I have 4 of them. And my team runs as part of a big organization. And so I run in a department, and there's another department that has another set of services running in a separate mesh. And maybe we share the same kind of root CA, maybe we don't. But we'd like to start talking to each other. Right? So how would I go about establishing trust? How would I go about establishing connectivity? And how would I go about controlling that? Well, the one thing we know about trust and certificates is we're used to using certificate authorities. Right? And certificate authorities are ways of saying, look, there are many certs that I'm going to accept identities for. If it was issued and signed with a key that is associated with this public key, I am willing to trust that it was generated by that private key. And so it doesn't just have to be one CA. Right? You can have multiple root CAs or multiple intermediate CAs, and you can federate trust that way. Right? So you can establish these organizational relationships with well-understood trust boundaries. And then you can say, okay, well, now I understand how I would talk end-to-end, and I can enforce access policies in those identities. Right? So we have federated trust. Now I want to control service exposure. Right? So in Istio, we have a feature today, which is basically just a gateway, right? Which is going to say this gateway will expose a certain set of services to this other network. Right? Just the same thing that you would see in an Ingress controller or an edge load balancer or anything else. Right? The one nice thing we do in Istio today is we have a feature, I don't know if Sriram talked about it earlier because I had to miss his talk, but we can route traffic not just based on HTTP or TCP, but we can also route traffic based on SNI. Right? In the TLS handshake, the name of the service is passed in the SNI header. The advantage of this is you can route traffic without terminating the TLS handshake. Right? So an edge load balancer can send traffic that is essentially where the payload is opaque, and the only thing that's provided to it to do routing is this SNI header. And that's the service name. Right? So you can use that to create end-to-end trust, right, where you don't have these powerful edge gateways that see all traffic, right, and therefore are superpowers and therefore at risk of attack, while still providing a useful kind of boundary between two different parties to control the set of exposed services. And then use that definition to create a kind of documented set of services that you can then publish to the partner you want to engage with, and they can now start calling your services. And that's just basic service discovery, right? There's a name for the service, and the endpoint for that service is the gateway, and you should talk to it using TLS. And that's it. Now you have federated meshes, right? I can go install a mesh over here, a mesh over here, establish mutual trust or some other form of trust, create a specification of the set of services I want to expose, establish routing without terminating trust end to end, and then publish that specification to my partner, and now we talk. So we have the kind of foundations for that in Istio today. We don't have an awful lot of usability or automation around it, but the fundamental plumbing is there. Right? And so that's pretty exciting, right? It lets organizations operate independently, right? You could have multiple meshes or you could have one big mesh. You could have two organizations with their own meshes, but they agree to share. And in my slide, I had cats and dogs talking to each other. Unfortunately, it slides. But right, that creates a lot of possibilities, right? And all of it is consistent with what we're doing today within a single mesh. There's no real distinction, right? The consumers of services don't really have to know, and you can create these very dynamic topologies with it, right? Whether you want a topology just to on-prem and in the cloud, or two companies that want to cooperate with each other, right? There are lots and lots of things that you can do. And so namespaces, and in particular the namespace identity model and how we do certificates, right, really starts to create this basis, this kind of foundation for these more advanced use cases. And it comes from my favorite feature in Kubernetes, which is namespaces. And if Kubernetes didn't have it, it would be the one thing we would have added it to the Istio API, right? It would have been the most important thing to have. So the other thing I was going to talk about in my slides, because people just often ask me, well, where is Istio? What has happened recently? Where are things going? So we just shipped the 1.1 release of Istio. And a major focus of that release was scalability. Right? We've been working with a couple of customers who are trying to roll out to production some pretty large deployments, right, where we're talking thousands of services, many thousands of nodes or pods. And that, that's a maturity thing for an early open source technology to kind of take on that type of deployment, which is why, in part, the 1.1 release is about 4 months late. It's because we were working through all their issues, but we have gotten them to the point where they feel comfortable going to production at that kind of scale. Right? So, when we said Istio 1.0 production ready means we're ready to help you get to production, and that's what we did. A big part of that was leveraging namespace as a scoping mechanism to control the amount of the network that any other namespace could see. Right? So this is the kind of declare what you use modality, right? If you're writing a microservices system, usually you don't want every service talking to every other part of the entire world, right? The early versions of Istio, we just distributed the entire configuration for all the services to every instance of Envoy. And that's going to work up to a few hundred services and maybe a few thousand endpoints. But once we got to that size, it wasn't going to work anymore. The other thing we found when we did that was there were also companies that had a similar philosophy but a different worldview, right? Which was the declare what you expose worldview, right? So I'm a service owner, and I know who I'm going to allow to consume me, and so I'm just going to say that. And that's easier for me to manage as information than asking all of my consumers to manage their consumption of me. So we actually did both. We have both features in the 1.1 release, and that has been pretty beneficial. There was a tweet, and unfortunately it was also in my slides, from a guy at AutoTrader who's been one of the early adopters of Istio and has been incredibly helpful to the project in just helping us qualify it and understand what's going on. And he rolled out 1.1 in production and started enabling the scoping features and saw his resource usage just fall off a cliff, which was great. So much, much more efficient when you start to actually scope the network. And a critical feature for us to get to as we go to these bigger deployments. And that was the major focus of the 1.1 release, right? Dealing with scale, dealing with organizational scale. And so now looking forward, what are the things that we would like to have in the next release? I would say the first thing is not to take 7 months to ship it. So cadence is our #1 feature. Beyond that, though, we think we've done pretty well on scale, so we want to focus on usability. And there are some key things that, I see plenty of grumbling about on issues and on Twitter and everywhere else. And if you have an axe to grind about any usability issue, I'm quite happy to hear it because we're taking all those requirements quite seriously. A big one would be around install and upgrade, right? So there will be an Istio operator. And there's already a lot of people actually out there developing operators, so we're just trying to get them all to work together and create one really good one. So that should be happening. We're also going to work on better command line utility, right, to help you understand what's going on in the mesh, and also to be able to provide automation for common operations that shouldn't really be in the control plane itself, right, that are going to pull together disparate pieces of information. That example that I just gave of federation is a good example of something that could be done by an outside tool instead of inline in the control plane. So we've already seen people do some of that with federation specifically today, but with outside tooling because it's not a feature that's shipped in the product. We're always interested in improving our test quality and our CI system, and that's a big part of our release cadence, so you'll see significant investment in that. And that's the basic thrust. I think the one other major thing that we hear a lot of usability feedback is the 0-day experience of Istio, like I got installed, it's working, is how much configuration or additional configuration I have to do to get it to do what it's supposed to be doing. A good example I hear often is a lot of people create services in Kubernetes, right? And they declare the port. But Kubernetes services don't actually explicitly declare the protocol. And so in Istio, we'd like to know what the protocols are because that enables features like routing for HTTP. And so we adopted a naming convention. We asked people to name Kubernetes ports, Kubernetes service ports, so we could figure out what the protocol is rather than trying to guess it. That creates a fairly large configuration burden on people to onboard. And so we're going to try and do some things to help people with more sensible defaults, or maybe do a little kind of content traffic detection so we can, in the most common cases, just make that determination on your behalf. And I think that would yield a lot of benefit to the user community for that 0-day experience. Right? Obviously, there are people out there who have a lot of deployment sophistication, who are quite happy to do Istio the hard way. I didn't quite get to catch all of the talk from the ING folks earlier, but I've had several hallway conversations with people doing some pretty sophisticated things with their installs and their setups. And we've certainly seen a lot of people build kind of more sophisticated CI systems on top of Istio to be able to figure out how to roll that in production. So that's kind of what's coming. I can't really tell quite how I'm doing for time, but I did want to leave some time for questions. Perfect. I'm happy to take questions on the past, present, or future of Istio. And also, I actually want to take a second to thank all the Istio contributors who are in the room, folks from all around the industry. I think Varun overstated in my introduction by far. There are many people who were involved in the birth of Istio, and they deserve just as much credit as I do. And several of them are here today. And if I don't know the answer to the question, I'll point one of them out in the room, and they can answer it for you, because they probably know the answer much better than I do. Do we have any questions? Over here. So most of the issues with mesh expansion are install, right? I mean, whether it's running on a VM or a pod doesn't make a whole lot of difference to the scalability of the control plane. There are some interesting things about the endpoint discovery and endpoint readiness and health checking that play a role in how quickly any given piece of workload coming up or going down can become live in the mesh for other things to talk to it. But it doesn't primarily impacts scalability. We'd like to say that, a well-run Istio deployment where things were properly scoped could, with a fairly straightforward installation, run for thousands to tens of thousands of services and tens to hundreds of thousands of nodes. And you can obviously then start partitioning things after that, right, to achieve greater scalability. Right here?
You talked to the concept of the namespace.
Yes.
And that's a way of creating, in a way, abstract way of thinking, creating its own environment, which kind of uplifts from the underlying hardware.
Yes.
Takes its environment with it. So in the journey of one of the area we are talking in the conference is brownfield adoption of Istio. How would that play a role in, say, putting Istio on a VM-based environment? Or there was a joke in the ING talk to put it on mainframe and things like that.
Yeah, so I'm not sure if I got this. So the question was, we talked about namespaces, this kind of generic abstraction that is separate from the compute model or the computing infrastructure that it's, where things actually run. And how does this play a role in kind of brownfield deployments? I try to be very clear, in the demo that, or in the slides, that as long as you can put a credential on something, right, that thing then becomes part of a namespace, because the credentials themselves are namespaced, right? So if you put a credential on something, you have delegated authority to that thing to be part of the namespace, right? That's what a certificate does. If I put a public certificate on a web server, I now own that name, right? So that's what we're doing. And then there's all the kind of the mechanics of how do you actually physically do it, right? Which can be quite complicated, right? Yeah, so you have, let's say I'm running a VM on vSphere or some VMware managed platform, right? How do you establish trust so you can get the credential that you need to assert that you're part of the namespace, right? What is that process? And if you look at what's going on in the SPIFFE community, right, both in Istio, Citadel, and Spire, right, which is another implementation of the kind of SPIFFE ecosystem, right? A lot of the work going on there is to figure out how to do attestation. Right? Attestation is the process of using environmental information to make some assertion that you can get a credential, and for the other system to be able to validate it. Right? And if you look on the cloud providers, they provide these kind of generic services that if you make a call within the context of a VM to a metadata service, right, they trust the network boundary between those two things, and so they're willing to give you a credential. Right? That's what happens on every major cloud vendor, as far as I can tell. Sometimes on premise, you might see TPM modules, right, which are physically coupled to the hardware in a way that's trustable. So it's that attestation process that matters, and it's very, very environmentally sensitive. And so what you really need is just a big, broad ecosystem of support for it, right? So that you, if you want to move your compute around, can move between different attestation systems and still establish the same trust that you want to establish. And that's a pretty dynamic and almost, it's not my primary area of interest, but there's a lot of people working on it, right? And there's been some really interesting open source projects and efforts in that area. Over here.
Is there any plans to support multiple certificates in the Ingress gateways?
In the Ingress gateways. Yeah, the question is, would we support multiple certificates on Ingress gateways? And the answer is yes. Yes, very much so. There are plans. And there has been some improved support for that actually in the 1.1 release. So Envoy has this API, the Secure Discovery Service, which allows you to load credentials. Right? You could either load them from the file system or load them by that API. We added some support in 1.1 to load credentials via that mechanism, right? Mostly, the primary use case for doing that was to improve rotation, right? Kubernetes secrets are, well, the dirty secret is they're kind of a pain. And if you want to be able to rotate them really quickly, right? And some people want to rotate certificates quickly because a long-lived certificate represents risk. So SDS helps with those types of things. But it also helps us load in certificates and more certificates into gateways for more typical kind of edge serving use cases.
that would be foundational for federation as well.
Oh yes, yes. That would be very useful for federation. So you'll see evolutions and improvements in the applicability and ability to bind multiple certificates and use them in more contexts. Like we still have a long way to go in that space for sure. But yeah, there's an easy road to plan through there. Over here.
Some earlier slides talking about there's like 3 ways on VM to get traffic into a sidecar, like IP tables, HTTP proxy, or like no traffic capture at all. That's why Istio only supported the IP tables route. Is there like a plan in there?
So we actually support 2 now. Sorry, repeat the question. Really, this is, how do you want to capture traffic flowing around in the mesh? How does Istio interpose on traffic? And the first thing that we did in Istio is we implemented IP tables so we could have a somewhat black box way of interposing in traffic, right? It just captured everything. And that works okay for some people. It doesn't work for everybody. And so we want to offer some ability to control the traffic capture mechanism, spanning a spectrum from fully black box, like eBPF, virtual Ethernet things, all the way over to don't do that at all, white box. And we've had some customers specifically roll out white box because they want the application to be aware of the sidecar and to leverage it. They want it to be intentional because they can do it, right? And it actually has some advantages. So we actually do now support that in Istio 1.1. We right now have these kind of 2 extremes. And so we'll probably see some more refinement in that over time. Over here. Sorry, I couldn't quite. The out-of-process adapter moved to a stable release? It's pretty stable, I think, in the 1.1 release. You could probably assume that any fixes would mostly be patches at this point to primary use cases. But that area of kind of extensibility and how we handle add-ons to the system is an area of kind of active investment and investigation to see if we can improve that further. I don't really have anything concrete to say about it at the moment, but we are looking into ways of making that much easier for people, and in particular, more performant, right? Because one of the things, we extract a lot of telemetry out of the data plane, right, and produce some pretty rich visualizations of it. Those come with a cost, right? And so we're looking at ways of squeezing that cost out of the system. Any more? I got the last one. How about over there? So the question was, any plans to support JOT revocation, JWT token, yeah, or blacklisting? So obviously, the Istio authorization policies enable you to blacklist identities, right? So you can use it as an ACL system, right? JOT revocation, right? JOTs are usually time limited. And so concerns around JOT revocation are usually about when you're subject to a replay attack, right? Because you've minted a credential that has too long a lifetime. We don't currently have anything specifically for that, though we would be looking at, certificate revocation, I think, probably before that. But I think it's something that we'd like to see maybe the ecosystem help with or contributions, right? So I certainly talk to plenty of people who are interested in that type of thing. It's just in terms of prioritizing it on the kind of the first class open source roadmap, it's not quite as high a priority. We have done things like, extended, what do they call them? Extended property expansion of JOTs, right? So you can call out to another service to get the remainder of the properties of the JOT, right? There's a spec for that. And you could obviously implement some form of revocation at that point, right? As long as you weren't aggressively caching the JOT transformation. All right, I think my time's up. All right.